So, welcome to the exam 3 trig review. I want to talk about this exam review real quick because some classes might be doing something different. In my class, I have actually made a cumulative final. So, when you go under the trig tab in the online math resources for students, if you look in the trig review test material, the final exam versions that you see here are the cumulative final exam versions. And then right here, those of you where exam 3 is the final, you'll want to look at version B in the solution guide. And we have the video out there. I just got to relink it. So those of you that are actually have exam 3 as the final, you're going to want to look at version B. Those of you that are have the accumulative final, you'll want to look at version A because this is really the exam 3 that covers chapter 11. Okay, there's only 20 questions in here. And we are recording this now, so that video will be out there soon. And we are going to make the solution guide as we go through this. Okay. So this is the version for purely exam 3 where it is not a final. Okay. And these final exams that are down here, these are a cumulative final that encompass chapter 9, chapter 10, and chapter 11. Those of you who have exam 3 or chapter 11 as your final exam, you're going to want to look at these two that are right here that are version B. And again, we'll have the video reposted back out there as soon as we can. So let's talk about chapter 11. So it pretty much goes in order. So this first piece is coming from 11.1, which is all about law of signs. Now remember, in law of signs, you have to be careful because you have to know about the ambiguous case, okay? So we've got this capital A that is 43.4 degrees. We've got this lowercase a that is 8.8. Sorry about that. Just want to make sure my email is off. And B, which is equal to 10. Now remember, the lowercase letters represent sides. The capital letters represent angles. Okay. So I'm just going to draw a quick triangle out here. And usually I let capital A represent the smallest angle, capital C is the largest, and capital B is the middle angle. So let me bring up what I've got. And they want to know how many solutions, I believe. How many possible solutions does this triangle have? In other words, they want to know how many triangles are possible out of this. 1, none, or 2. Okay, so this is going to be my 43.4 degrees. This is going to be your little a because the little letters are directly across from the capital letters. So this is the 8.8. That's our little a. Since this is capital B, directly across from that is the lowercase b. And as you can see, you've got the angle side-side case, or as the book would put it, side-side angle. So you got to be careful of this one because this is the ambiguous case. If this was not the angle side-side case, then you'd be looking at for possibly wanting to know if you have the side angle case, or angle side as I call it, or angle side angle. Okay, because for law of signs, we use the angle side case and the angle side angle case, as well as the angle side case, the AS case, for law of signs. Okay, so since this is angle side, we are going to be checking law of signs, and we do have to watch out for the ambiguous case. That's what we have here. So we either have 0, 1, or 2 triangles. So how do we deal with this? Well, the first thing that you guys are going to do in the ambiguous case is you are going to find the missing angle for B. Okay? So we're going to find B right here first. So we're going to have 10.1 over sine B equals 8.8 over sine A. Oh, sorry. We know what angle A is. I should have put that in there. So it should be not sine A, but sine 43.4. Fix that real quick. There we go. So 43, not writing very well because I'm writing over whiteout, 0.4 degrees. So remember, all you're going to do is cross multiply. So we're going to have 10.1 times sine 43.4. So 10.1 times sine 43.4 degrees equal to 8.8 times sine B. 8.8 times sine B. Now we want to get sine B by itself. So we're going to divide by 8.8. So sine B is equal to 10.1 sine 43.4 degrees divided by 8.8. And in order to get the angle by itself, this is where we take inverse trig. That's why we spend a lot of time in chapter 10 talking about inverse trig to solve. So B is equal to, let's go to our calculator and let's have it run it. Okay, so inverse sine, and we got alpha y equals 10.1 parentheses sine. Make sure we are in degrees, and we are in degrees. 43.4. Close, close. Make sure you watch all those parentheses and close them up. 8.8. Scroll out to the side, close it. So this actually gave us an answer. So that means we know that we now at least have one or two triangles, because this actually gave us an answer. Okay? So, with that being said, now, how do you know how many triangles you've got? Well, here's what we're going to do. So I'm going to write down this angle, 52.05385316, and that's degrees. So that's one possible measure of angle B. Well, we're going to take 180 degrees minus that angle, okay? So 52.053855316 degrees, okay? We're going to subtract 180 from that. So 180 minus that angle gives us 127.9461468 degrees. So this is what the other angle of B could be in another triangle. So, but we have to check this, okay? We know this one's good, so we know we have at least one triangle, but the question is, can I have an angle B be 127.9 blah, 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 blah. So what we're going to do is we're going to take angle A, the 43.4 degrees. We're going to add that with the 127.9461468 degrees, and we want to make sure that this is, or check to see if it is less than 180 degrees. If this is less than 180 degrees, then we have two triangles. If this is over 180 degrees, then you only have one triangle, okay? So if we go back to our calculator, we take 43.4 plus this angle right here, we get 171. So that means Since this is indeed less than 180, we have two triangles. So this is one angle B. This is the other angle B. But again, they didn't really care about that, but we do have two triangles here. Okay? And that's what they want to know in the blank. So how many possible solutions does this triangle have? Two. Because there are two possible triangles in the end. Okay? So there's that first one. Right off with the ambiguous case. Okay? All right, number 2, still an 11.1. And basically, this chapter is all about demolishing your triangles, learning everything you can about them. So, and number 2, no surprise, they give you some information in the picture, and then they want you to solve the triangle. So 47 degrees, 61 degrees. A is equal to 14 meters. C, little b, we got a capital C, a capital B, and a capital A. All right, so here's what we got. And then they want us to find capital A, little b, little c. No worries on that. All right, so to find capital A, that's pretty easy because all the angles inside a triangle must add up to 180. So we're going to take 180 degrees minus 47 degrees. Let's make sure that that looks kind of like a better 8. 180 minus 47 minus 61 degrees. And that gives us, I don't know off the top of my head, so let's just use our calculator. 47 minus 61. And that's 72 degrees. And oh, this is the angle side angle case. Okay. This is the angle side angle case. So that means we are definitely using law of sines. Okay. So that hasn't changed for us. All right. All right. So there's our first angle. There's one of our answers, 72 degrees. Now to find the rest of the stuff, all you're going to do is set up a proportion and solve. Okay. So we now know that in order to solve for C, we can use this 72. I hesitate to use angles that we already know, but because this is a nice, neat answer, it's okay to use that. Really be wary of using rounded answers to help you find another answer where you're going to round again. That's bad math. But because this is exact, we're okay on that. I'm okay to use this answer again. So 14 over sine 72 degrees, because we just found that for angle A, equals B over sine 61 degrees. So all we're going to do, just like before, is cross multiply. So that's going to give us 14 sine 61 degrees equal to B sine 72 degrees. Divide by sine 72. And now you know what B is. B is going to be this guy. So let's just go to our calculator. Let it do its job. A lot of calculator work on this. So alpha y equals 14 sine 61. Close, close. And sine 72. And we get 12.874 blah, 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 blah. But let's go back to here. That says round to the nearest degree for A. So we already did that. Down here, it says do not round until the final answer. So then round to the nearest hundredth. So hundredth is 2 decimal places. So 12.87 meters. There's our answer for B. 12.87 meters. C will work the exact same way. I'm going to use the 14 over sine 72. Okay? Because again, I don't want to use this. This was a rounded answer. Don't use this to help you find C. Okay? We know that these are nice answers right here. All over C equals sine 47 degrees. So again, you just go back to cross multiplying. So this time it's 14 times sine 47 degrees equal to C times sine 72 degrees. And then you just divide by sine 72 again. So we're just going to go back in. I'm going to grab that same fraction and change the 61 out with a 47. And we're going to round to the nearest hundredth. All right. So I'm going to come up here, grab that fraction, come right in here, scroll over and change that out with 47. And boom. So rounded to the nearest hundredth, we get 10.77 meters. And there you go. There are the answers to number 2. 72 degrees, 12.87 meters, 10.77 meters. Okay. Number 3 is a lot like this, still in 11.1. Okay. So even right here, it says use law of sines to solve this. Okay. So I always like to draw a picture with my information. So I've got A, capital B, C. Well, let's make it consistent with all the other pictures that I've drawn. I accidentally put B at the top of my triangle, and I usually put C up there. I want to be consistent. But it doesn't really matter. Does not really matter. So that's C. The little c is over here at 6 miles. And that means we're looking for the big A, the little a, the little b. C and B. And we know that B is 36.73 degrees and C is 33.32 degrees. All right. So I've got a picture because I always like to have a picture. So if we look at this, this is actually the angle side case. And again, that is, verifying that is law of sines. It's not the ambiguous case, so we don't have to worry about double triangles or anything like that. So again, to find big A, not hard. All we're going to do is take 180 minus these angles. Minus 33.32 degrees minus 36.73 degrees. Okay, just going to go to my calculator, work all that out. I'm not going to show this one like I did last time. I'm just going to use the calculator I got in my hand. 32 minus 36.73. And so angle A is 109.95 degrees. And I'm sure it's going to want us to round to 2 decimal places. Actually, it says type an integer or a decimal. So that 109, this 109.95 is actually going to become 110 degrees. Okay, be careful about using that if you plan to use it, because this is a rounded answer to use to get other rounded answers that you're going to see here in a second. Okay, everyone else says round to the nearest mile, so whole number. All right, so we're just going to find all this information the same way that we just did it a second ago. Okay, so in order to find B, I'm going to have B over sine 36.73 degrees equal to 6 over sine 33.32 degrees. Because I like these two because these pair up and I know that these are correct. Okay, and then I'll just use the same setup to help me find little a. Okay, although when I do little a, I'm going to go back and use this angle that's right here because I don't want to use the rounded one because that will create too much rounding for me. So use this one. So little a will be over sine 109.95 degrees equal to 6 over sine 33.32 degrees. Okay? So much better to use the exact answers that you know instead of using the rounded ones. So just be careful of rounding because it'll get you on this. So in here, this will give us B of sine 33.32 degrees equal to 6 of sine 36.73 degrees. Divide by 33.32 degrees. Oh, sorry. Divide by sine 32.32. Sine 32.3. Sorry, 33.32. And then over here, you'll have A of sine 33.32 degrees equal to 6 times sine 109.95 degrees. And then again, you'll just divide by sine 33.32 degrees. Okay, so let's talk about little a and little b. All we're going to do is go to the calculator and let it do its job, and we're going to round to the nearest whole number, okay, the nearest mile. So I'm going to go to my calculator, alpha y equals, we're going to have 6 sine 36.73, close, close, all over sine 33.32. And again, I'll just grab this fraction and use it for the next one real quick. So little b, because that's this little fraction was for little b, rounded to the nearest whole number is 7 miles. Okay? Because the 5 says, hey, 6, round up. Go up, grab my fraction. So all I got to do is change this top value to, oops, too far. Change this guy to 109.95 and close, close. There we go. Enter. So little a is 10 miles. So if we go back, there's our answers right there. 110 degrees, 10 miles, 7 miles. And that's what would go in their blanks. Okay? All right. So question number 4. This is the last one. Yeah. This is the last one from 11.1. Law of sines. All right. So they're giving you a word problem. Notice that this is in minutes right there, so be careful. I'm just going to draw the picture because the pictures are really what help us along in this. So 13 degrees, 16 minutes, and then got 114 degrees, 12 minutes, and 315 meters. B, C, A. And they want us to find the length from A to B. Okay? All right. So this is what you're looking at. They want the length from A to B. This is that picture. So we'll definitely use law of sines here because this is angle, side, angle. And you use law of sines for angle, side, angle. Okay. So what we're going to have then, we're going to need to figure out this angle right here first. okay? Because we don't really have everything to set up here because we've got X and it will go over sine of 13 degrees, 16 minutes. And that will equal, well, we want to use the 315, but we don't have the angle for big A yet. So that's what we're missing here. So that's why we got to find this guy first. Okay. So again, to find big A, not hard. 180 degrees minus 414 degrees, 12 minutes, minus 13 degrees, 16 minutes. Okay. So we can just go to our calculator and let it do its job. So 180. And remember that you're going to hit second apps, degrees, minus 114 second apps, degrees, and 12 second apps, minutes, minus 13 degrees, 16 minutes. And there's our angle. Now they gave it to you as a decimal, which there is nothing wrong with that. So this is what it is in degrees. But if you want to turn it into minutes and seconds and all that, just hit second apps, scroll down to number 4, degrees, minutes, and seconds. And there it is. So 52 degrees, 32 minutes. Okay. Now, here's kind of the problem. If memory serves me right, sine doesn't really like to run with minutes and things like that. Okay, let me just double check that. Sine 52, I'm pretty sure. But it's been a while since I ran sine with degrees and minutes. So 32. If this runs, then we'll be okay. Oh, it did run. So we're good. So never mind. Just kidding. So 52 degrees, 32 minutes. So now we can do all of our cross multiplying and solving. So we're going to have x of sine 52 degrees, 32 minutes equal to 315 times sine 13 degrees, 16 minutes. To get x by itself, divide by sine, and this was number 4, 11.1 still. Sorry about that, didn't say that. So 52 degrees, 32 minutes. Sine 52 degrees, 32 minutes. Okay. So they want us to round. Let's double check that. It says round to the nearest whole number. And hopefully this should be easy answer for you because this is in meters. So this guy has to also be in meters. So you know this blank over here, one right there, has to be meters. We just got to figure out the number. So let's run it. So alpha, y equals, we've got 315 sine 13, 16, close, close, all over sine 52. Oops, not a decimal. And second apps, 32 minutes. There we go. Close it up, hit enter. And to the nearest meter or whole number, 91. There you go. There's the answer. So you're going to put 91 in the first blank, and then you'll select meters for the second blank. Okay. Again, you always want to be as accurate as possible. So there's our answer, 91 meters. All right. Question number 5, moving on to 11.2, law of cosines. No more ambiguous case. Yay. All right. So law of cosines, remember that worked when you had side angle side and side side side. But you got to be careful when you run those cases. But law of cosines works when you have side angle side and side side side. All right. So with that being said, let's do some here. Let's do some law of cosines. So here, you can see that you got side angle side, and we're just demolishing the triangle. Okay? All right. So they want us to find big C, big B, little a. All right. So the first thing you're going to do here, because we are dealing with, let me show you. So this is side angle side. So that's definitely law of cosines. Side angle side. So the first thing you're going to want to do with side angle side is we're going to use law of sines, or excuse me, cosines to find the third side. So we're looking for A, okay? So our formula will look like A squared equals B squared plus C squared minus 2BC cosine big A. Okay, the side you're looking for is squared here. It's kind of like a Pythagorean theorem where you're taking off a little piece of it. It's what it kind of looks like. All right, so let's just fill in. So A, little a, well, we don't know. So that's just going to stay A squared. B, well, that's the side across from the 8. So 8 squared. C, little c, is 22. Minus 2, and that's a square right there, times 8 times 22 times cosine of A is 25 degrees. All right, so it's just basically this is just some math that we're going to let our calculator do, and in the end we're going to take that number and square root it. So if we just go to our calculator, sorry, I didn't mean to cover that stuff up. We're going to put all this in the calculator. Just the way you see it, 8 squared plus 22 squared minus 2, 8, 22, and cosine 25. There it is. So there's our number. So 228.979659. But remember that this number is squared. So we're going to take the square root of it. So we're going to hit second x squared. Come up and grab our number. There it is. And that's the answer for A. Now it wants us to, it says, round to the nearest whole number, even better. So A is 15. Okay? So there's little a. All right, now, to get the other pieces, you got to be careful here. For side angle side, we're going to use law of sines to find the smaller of the next two angles. So we're going to use law of sines to find the smaller out of these two angles. So when I look at these, this is obtuse, this is acute. So we're going to use law of sines to find B. Okay? So when you've got side angle side, you're going to use law of sines to help you find the smaller of the two remaining angles. Okay? Now, let's do that. But you need to be careful because we're going to have to use A on this. And so I'm not going to use 15, but my calculator has the real A value that's right there. And that's the value I'm going to be plugging in each time I do this. Okay? So it's very important that I use this number and not a rounded one, because this is more exact. It's going to help us out. I know it's more of a pain in the butt, but we've got to do it so that way we don't end up with rounding error. So we're going to find sine B first. Well, we know little b, which is 8. And then we got to use this guy because this is the only angle we have. So that's sine 25, which is all about little a, which is this number that I'm going to use right here. I'm not going to use just 15. I'm going to use that number right there. I need to be as exact as possible. 207,385. Okay, so we'll cross multiply. So that gives us 8 times sine 25 degrees. You don't have to worry about the ambiguous case anymore, just so you know. And then this will give us 15.13207,385 times sine B. To get sine B by itself, divide by the 15.13207,385. 0.13207,385. So sine of B is equal to 8 times sine 25 degrees all over 15.13207,385. How do I get B by itself? Sine inverse. You got it. Sine inverse. Muy bien. So B equals, we're going to go to our calculator, let it do the heavy lifting. Okay? So, second, sine alpha y equals 8 parentheses sine 25, close, close. So let's see what it does when I do this. Grab that. Nope, didn't put it in the spot I wanted it. Oh, shoot. I just undid everything. Easy fix, though. All right, so second sine alpha y equals. So we can't just go up and grab that number. We're going to have to actually type it in. 8 parentheses sine 25, close, close. And then come down here and push 15.13207,385. There we go. Scroll it to the side. I like to close it. And there is angle B, which is 12. What does it want us to round to? Let's check that out. Nearest degree. So 13 degrees, because the 9 says, hey, round up. So 13 degrees. Fixing my answer key real quick because I wrote 12. But again, I'm going to want to hang on to this 12,910,522,53, because that's the real angle. Okay. So to get our last angle C, all we're going to do is take 180 minus the angles that we know, which is why I want to hang on to that 12.91 there, because all I'm going to do is take 180 degrees minus 25 degrees, because that was angle A, minus the 12.9105223, and that's going to tell us angle C. So 180 minus 25 minus, I can go out there and grab this guy this time. And there's angle C. Rounded to the nearest degree is 142 degrees. And there we go. So what we would put into our little blanks, right up here, A would be 15. Okay. And Measure of angle B will be 13 degrees. Measure of angle C will be 142 degrees. And there you go. So be careful on this. When it is side angle side, after you use law of cosines to get the third side, you're going to find the smaller of the two missing angles. And that's going to be B. Okay, well, in that case, it was B. All right, number 6. Demolishing the triangle again. This time you have side, side, side. And again, this is 11.2. I'm going to draw out my picture because I like to draw my picture. B, C, A, 15, 27, 14. Okay. So they want us to find all the missing angles. All right. So again, we have side, 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 and that's a law of cosines to start out with. So we're going to use law of cosines, and when we use law of cosines, we want to find the biggest angle. So the biggest angle for us is going to be C. How do I know that? Because this is the largest number. The side that has the largest number, the angle across from it is the largest angle. Okay? So we're going to be looking for C here. So that means we're going to be using C squared equal to A squared plus B squared minus 2AB cosine C. So we're going to fill that in and we're going to find cosine right here. So C is 27 squared equal to A, which is 14. I always like to use the right numbers because, well, technically it doesn't really matter in that part right there, but it's good to make sure that you have the correct number. So the real little a is 14. I'll come back to that because that's drawing. 15 squared minus 2 times 14 times 15 cosine C, 14 squared. So we're going to need to do some math here. So we're going to need to figure out the 27 squared, the 14 squared, the 15 squared, and bring them all over on one side. So just using my calculator, I'm not going to bore you with punching it in on the calculator on the computer. So 729, 14 squared is 196, plus 15 squared, which is 225. Minus, well, we can figure this part out real quick right here. So 2 times 14 times 15, 2 times, sorry, had an extra number there. So this is 420 cosine C. So first things first, I'd combine these two together, 196 plus 225. So this is 729 equal to 421 minus 420 cosine C. So let's just get cosine by itself now, just moving numbers. So minus 421, minus 421. So 729 minus 421. So that's 308 equal to negative 420 cosine C. Divide by negative 420. So 308 divided by negative 420 is negative 0.73 repeating equal to cosine C. How do I get C by itself? Cosine inverse. Yes, you guys are so good. Cosine inverse, both sides, cosine inverse. So we're going to take the inverse of negative 0.73 repeating. Okay? And that's going to tell us exactly what C is. And let's see here. They want us to round these 2 decimal places all around. All right, 2 decimal places. So second inverse, negative 0.7. And since this is 3's repeating, all I'm going to do is hit 3's a bunch of times. And I mean a bunch of times. See, look, I'm hitting it a bunch of times and then close it off. Because hitting 3 a bunch of times after that lets your calculator know, oh, this 3 is repeating. Okay, your calculator's smart enough, it actually figures that out. So there's our angle. Rounded to 2 decimal places. So 137.17 degrees. But again, I'm going to hang on to this 137.1665719 because I don't want to use a rounded answer to help me figure out other rounded answers. Okay? All right. So, oops. Here's what angle C is. And now we can do this. So when it comes to side, 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 when you do law of cosines, you want to find the biggest angle first. Now we will use law of sines, but the cool part here is you don't have to worry about which angle you find next. It doesn't really matter, okay? Doesn't really matter which angle you find next. So we can either find A or B. I'm going to go ahead and find B, and then we'll get A in the end. So angle B, we're going to have 15 over sine B, because the 15 is across from the B. So 15 over sine B equal to your C length, which is 27, over, and I'm going to put in my big angle right here. I don't want it rounded because I want this answer to come out as exact as possible. Okay. So there we go. All we got to do now is cross multiply. So that gives us 15 sine 137.1665719 degrees equal to 27 sine B. Divide by 27, divide by 27. Sine B is equal to 15 parenthesis sine 137.1665719 degrees all over 27. How do I get B by itself? Sine inverse. You guys are so smart. You're so good. I'm so proud of you. So B is going to be equal to the inverse of all this jazz. So let's go to our calculator, let it do the heavy lifting for us. Second sine alpha y equals. So we got 15 parenthesis sine. Can't come up and grab that number. I wish I could. 137.1665719. Close it, close it. And on the bottom, 27. And I like to scroll it to the side and close it all up. There we go. And there's what B is. 2 decimal places is 22.19 degrees. And again, I'm going to write down this angle because to find the last guy, I want to make sure it is as exact as possible. And just like before, to find the last angle, all we're going to do is take 180 minus these two angles. 180 minus the 137 minus the 22. And our final angle A, sorry, got to switch a piece of paper. Our final angle A was 180 degrees minus the 137.1665. I'm writing up the answer keys, so sorry that it's taking me so long to get through this problem. 160658. 2 decimal places is 20.64 degrees. And there we go. So when we go to our page here, in A, you're going to put 20.64 degrees. In B, you will put 22.19. In C, you will put 137.17. And there we go. All right. Here is your word problem. So 11.2 again, still in law of cosines. They want to know how far are the houses apart from each other. A and B, 100 feet. It's a 50-degree angle and 70 feet. So again, what you have is side, angle, side, side, angle, side. So side, angle, side is law of cosines. Okay. So to find this, it's basically, really any of those law of cosine formulas where your x is going to be the squared part over here. And then it's going to be equal to 70 squared plus 100 squared minus 2 times 70 times 100 times cosine 50 degrees. And that's what you got. Again, just like before, kind of like just like our first problem, number 5, we're going to go straight to the calculator, let it do its work. We'll figure out x squared first, and then we'll just take the square root of it. So go to our calculator, and we've got 70 squared plus 100. Oops, I had to put parentheses. 100 squared minus 2 times 70 times 100 times cosine 50. And close up. There's our number, 5,900.973464. And then all we're going to do is take the square root of that. So second square root, grab, boom, boom. So they are 70, let's see here. What does it say to round to? Nearest hundredth, so 2 decimal places. So 76.82 feet. And there we go. So in here, 76.82 feet. Okay. The last two are still in law of cosines, but these are where we learned about the area formulas. One of these is the straight area formula using cosine. The other one is the Heron area formula. Remember that Heron works for side, side, side. And then the other one works for side, angle, side. So if we're looking at number 8, and I draw a quick picture, A, C, B. Looks like I know angle A is 12.6 degrees. I know little b is 12.3 meters. Little c is 5.9 meters. So if I look at this, this is definitely side, angle, side. So side, angle, side is going to use the area formula of, I always end up messing this thing up. A equal to 1/2 B C sine A. I usually put cosine there because we're in the law of cosine section, but there we go. That's what you guys are going to be using. So all you're going to do is fill in and kick out an answer. So 1/2 B, which is 12.3, C, which is 5.9, sine of A, which is 12.6 degrees. Just go to your calculator, let the big dog eat. So alpha y equals 1/2 parenthesis 12.3 5.9 sine 12.6. Close it all up. And there is our area, and they want us to round to the nearest tenth. So that'll be 7.9 meters squared, because area is always squared. All right. So in that blank goes 7.9. Number 9. Number 9, still an 11.2. This one is going to be your Heron formula because it's all sides. Okay. So 105.7 meters, 78.5 meters, and 100.2 meters A, C, B. So the first thing you have to do with the Heron formula is you have to figure out what is called the semi-perimeter first. Okay? The semi-perimeter is 1/2 A plus B plus C. Okay? So you just fill in 1/2 of 78.5 plus 105.7 plus 102, or 100.2. And we're going to figure that number out. No rounding. Not on this one, because we got to have that number. So we're going to have alpha y equals 1/2, parenthesis, 78.5 plus 105.7 plus 100.2. And again, this is what we call this semi-perimeter. So 142.2. And then now we're going to use that in the area formula, which looks like this. Square root of S, and then it is S minus A. Making sure on that. Yeah. S minus A, S minus B, S minus C. Okay? So all you have to do is plug in the A, B's, and C's and the S, and then let the calculator do its job. Okay? So A is equal to square root 142.2 times 142.2 minus 105.7, 142.2 minus 78.5, and 142.2 minus 100.2. Just go to your calculator, let it do its job, okay? And they want us to round to the nearest square meter, so the nearest whole number on this. All right, so second square root and 142.2. And then 142.2 minus 105.7. 142.2 minus 78.5. 142.2 minus 100.2. Hit enter. To the nearest whole, 3,726 meters squared. Okay? There we go. All right, and that takes us out of really kind of the long stuff. I think section 11.1 and 11.2 is the longer part. So now we're going to start into 11.3, which is all about vectors. There was lots of information in there about vectors. So in this one, they just want to know which is the opposite vector. Okay, So I'm going to kind of draw this graph a little bit so we can talk about the opposite vector. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. All right, so I'm just counting by ones here. And it looks like we got a vector that kind of looks like this. So this is vector B. All right. Wrong page. So there's my vector B. If I want to do the opposite of this, that means all you do is you just switch the direction. So it goes out here to positive 3, 3. Well, if I switch the opposite direction of that, instead of going up 3, I'll go down 3. Instead of going to the right 3, I'll go left 3. So I need negative 3, 3. This is the opposite vector. Okay? So if I come back to this, there's only one picture that looks like that, and that's A. Okay? That's the opposite vector. You just switch the direction. All right. Over here, number 11, still an 11-3. So the next few questions. All they want you to do is take these vectors A and this vector B, and they want you to add them. Okay? So let's talk about that, because there are two ways that you can add these. So let me show you. So one way is, and we're looking at A plus B because that's important, is to draw the first vector, which is A. Yeah, it should be more up, but that's all right. And then right at the end of A, where it ends, you draw vector B. And when I connect from the beginning to the end, that is A plus B. So that's one way. Or they have what is called the parallelogram kind of vectors. And if both vectors have the same starting position, like this is vector A, this is vector B. Well, imagine that if we complete the parallelogram. This is kind of horrible on my part. This one should be more angled. Close enough. So imagine if I completed the parallelogram, like I put another vector B here and another vector A here. These two vertexes that are opposite each other represent that diagonal of A plus B. So they're going to do one of these two things. Usually they like to do the parallelogram one, where they draw the picture of the parallelogram. And again, the end arrow, when you add them together, is always at the end here. So we started here, we ended there. That's where the arrow of A plus B ends. We started here at the beginning, and then we ended right here. So that's where the arrow goes. So keep an eye on those arrows, because they like to kind of throw you off. So let's go back and let's look at our pictures. So here, it started here, they continued, and then they drew that line right there, but look where the arrow is. That arrow for A plus B is down here, and that's not correct, okay? Remember, as I showed you, if they were doing that, the arrow should have been up here at the end of B, okay? They should have been in the same spot. So that's out. So here is A, here is B, and they said it started here and it ended out here, and that's A plus B. This one is that parallelogram picture that I drew, okay? So the real answer to this is B. Now let's look at the other ones. Obviously, this one doesn't work because it says that it's from the end of A arrow to the end of B arrow. So they tried to do the parallelogram here, but they connected the wrong diagonal. So if you look at this, see the diagonal is from the beginning to the end of their parallelogram, not from arrow to arrow. This is the one that they connected. That's wrong. Okay? And then the last one, This is the wrong order. It said it started with B and then ended with A. That's not correct. It starts with A and ends with B. Okay? So incorrect. So it has to be B. So just keep an eye on that. All right. Number 12. We're almost there. Almost there. There's only 20 questions. 11.3. So all you're doing here is you are doing some vector adding, subtracting, and multiplying. That's it. Okay? So, and they are giving you your vectors in unit vector form. So we know that vector u is 9i. Vector v is 5i plus 3j. Now remember, if you don't like unit vector form, you can always change these, just so you know. Where I represents kind of like the first component in the vector, j represents like the second component. Think of like I as like the x value and j is the y value. So since there is no j here, you can call it 0. And that's really what the vector u looks like in vector components, not unit, okay? Vector v really looks like 5, 3. So if you don't want to deal with it like this, you can always take it out. It's your call. But really, all they want you to do is take 4 and multiply it by 9i. Or, again, like I said, is taking 4 times 9, 0. It's like you're going to distribute it through. Well, what is 4 times 9i? That is 36i. If you would have multiplied this down here, let me erase that in parentheses, you would have gotten 36, 0. But the directions, they do want it in I and J. They want it in the unit vector format. Okay? So in the end of this, you would have gotten 36, 0. Because 4 times 9 is 36. 4 times 0 is 0. Okay? But they do want it in this form. So you just put 36i. Okay? Because there is no j component. All right, B. So here they want you to multiply the vectors and then add them. Okay? So nothing crazy here. So you're going to take 4 times 9i, which you pretty much already know the answer for that from up there, plus 2 times 5i plus 3j. Or again, you could do it vector style, just regular vectors. So 4 times the vector 9, 0, plus 2 times the vector 5, 3 to get to that answer. Okay? So all you're going to do here is you're going to get 36i plus 10i plus 6j. Now all you do is you put like terms together. So in the end, for part B, these two components are going to get together and give you 46i plus 6j. If you would have written this as just regular vectors, it'd be the vector 46, 6. Okay? Again, you can get the same answer using this. It's all your call. And last but not least, I believe they want us to subtract this time. Yeah, they want v minus 2 times vector u. So vector v is 5i plus 3j minus 2 times vector u is 9i. So in the end, I'm not going to show the vector piece because hopefully you've got that. You got negative 2 times 9, which is negative 18i. putting like terms together, that gives you negative 13i plus 3j. That's what they want. Easy peasy, okay? There's our vector u and v. All right, 13, moving along, still an 11.3. Okay, 13 says, find the vector. So what they're giving you out here, they want to know what is vector u. They want the x component, they want the y component. Well, I call it x and y, okay? They want the horizontal component and the vertical component is really what they're called. We're going to round to the nearest thousandth. Now, what they are telling you here, this 2 is the magnitude. So we know the magnitude of vector u is 2. And then this is our angle or the direction. So this is our theta, negative 55 degrees. Okay? All right. So again, this is what magnitude looks like. It kind of looks like absolute value. It's not absolute value. It's just magnitude. Okay? So in order to find the horizontal and the vertical component, that's what they're looking for here. And we're going to round to the nearest, I think it said 100th, 1000th. So 3 decimal places. In order to find this component right here, the horizontal, okay, you're going to take the magnitude times cosine theta. This will find the horizontal. In order to find the vertical, you're going to take the magnitude times sine theta. So in other words, we're taking 2 times cosine negative 55 degrees. And we're going to take 2 times sine negative 55 degrees. Okay? So we just go to our calculator and again, let it do its job. So 2 times cosine, I'm going to actually put the multiplication sign here. 2 times cosine negative 55, close. So the horizontal component to the nearest thousandth is 1.147. So then all we're going to do, I'm just going to come back up here, grab this guy, and change cosine to sine. The sine, or the vertical component, is negative 1.638. And that's what they want. That's what's going to go in the blanks there. 1.147, comma, negative 1.638. And that's it. All right. So moving on, number 14. $11.3 still. Okay. So they want you to find the magnitude and the positive direction angle. All right, so let's talk about how we do this. So it's kind of like we're reversing some information. So here's our vector. So in order to find the magnitude of the vector, we'll just call this u. Since it didn't really give us a name, we'll give it a name, u. So to find the magnitude, all you're going to do is take the square root of each piece squared and added together. Negative 2 squared root of 3 squared plus negative 2 squared. Okay? So just doing this in my head, if I square the square root, I get 3, and negative 2 squared is 4, so this is 4 times 3, which is 12. This gives me 4. So I'm looking at the square root of 16, which is 4. So there is the magnitude. It is 4. To find the angle, I'm going to look at tangent theta equal to b over a, kind of like y over x. Okay? So I need tangent theta of -2 all over -2 square roots of 3. Well, if I do some reducing and some fixing here, I'm really looking at tangent theta of a negative over a negative is positive. 2 divided by 2 is just 1. It cancels out, but I need to rationalize. So multiply it by the square root of 3. I end up with the square root of 3 over 3. I don't know if that's on our trig table or not. Actually, it is. So we want tangent to be a positive square root of 3 over 3. Okay? A positive square root of 3 over 3. Well, that happens in 2 places. Okay? Because again, you're going to be taking the inverse here. And you can look this up. So that happens in 2 places. Tangent is the square root of 3 over 3 at 30 degrees. And it is the square root of 3 over 3 at 210 degrees. Now, how do you know which one we want? Because we only want one answer here. Well, go back to this. Think of this again like a coordinate point. What coordinate point has a negative x and a negative y? Well, that would be a point that is in quadrant 3. There's only one number down here that is in quadrant 3, and that's the 210 degrees. So that's what they want. There's the magnitude. There's the angle, 210. Okay? All right, number 15, moving on, still 11.3. Lots of 11.3 questions because there was a lot in there. So the next one, it wants you to find the angle between these 2 vectors. So let's just call it vector u, which is 4I minus j. And we'll have vector v, which is j. Okay? So in order to find the angles between these 2, there's a formula. Lots of formulas for you to know. And that formula is cosine theta. Oh, would help if I'm on my page. Cosine theta equal to u dot product v all over the magnitude of u and the magnitude of v. Okay? Now, when we do dot product, just so you remember, when you take the dot product of 2 vectors, you get a times c plus b times d. Those are their vector coordinates, okay? So if I change this into its vector, this is 4, comma, -1. This is your a, this is your b. If I change this guy into vectors, there's no I, so that's 0, comma, a j, but the number in front of j is 1. This is your c, this is your d. Okay? So the first thing is we need to find some dot products. Then we also need to find the magnitude. Okay? So a couple things that we got to do, and then we're going to plug into this thing. So the dot product of u and v is going to be a times 0 plus -1 times 1. Well, 4 times 0 is 0, and -1 times 1 is -1. 0 plus -1 is -1. There's the dot product. The magnitude, we've already talked about how to find those. So the magnitude of u is equal to the square root of 4 squared plus -1 squared. So that's 16 plus 1, which is square root of 17. So there's the magnitude of u. The magnitude of v is equal to square root of 0 squared plus 1 squared. And that's just going to be 1, because 0 squared is 0, 1 squared is 1. So this is 1. Square root of 1 is 1. All we have to do now is plug in our pieces of information here. So cosine theta is equal to, the dot product is -1 all over square root of 17 times 1. Well, in the end, before I get to doing the inverse, you end up with -1 over the square root of 17. So you got to rationalize. So cosine theta is equal to negative square root of 17 all over 17. So this is what we need to take the inverse of. And then we'll know the angle between our two vectors. So go to our calculator, and second cosine alpha y equals negative second square root 17 all over 17. Scroll out to the side, close it up. Boom goes the dynamite. 104, let's see here, what does it say? Nearest tenth, so 1 decimal place. 104.0 degrees. And there we go. Number 16, which is the last of vectors. Number 16, which is the last of our vectors. So 11.3. They want to know, are these orthogonal? In order to be orthogonal, all you have to do is look at the dot product. If the dot product is 0, they're orthogonal. Orthogonal means, are the vectors perpendicular to each other? That's what orthogonal means. Are they perpendicular to each other? So all we have to do is take the dot product of these. Okay? So this is my A, B, C, D. So A is 1 times 0 plus my B is negative square root of 2 times a negative square root of 2. So that's 1 plus a negative square root of 2 times a negative square root of 2 is a positive 2. 3. So are my vectors orthogonal? No. If this was 0, then we would have answered yes. All right. Not much left. The next one is 11.6. You do not have to worry about 11.7. So 17, 18, 19, and 20, the next 4 problems are all 11.6, and that's it. Okay. So let's jump into this one. So it says plot the point, okay, -5, 210 degrees, so that's the polar coordinates. And then we want to determine some other equivalent points. And then we want to provide the rectangular coordinates for this. Okay. So the first thing is, when we graph this, you're going to graph this as if this is a +5, okay? You're going to graph that as if it is a +5, okay? Super important on that. So graph it as if it's a +5 first. So 1, 2, 3, 4, 5. 1, 3, 4, 5. 2, 3, 4, 5. 3, 4, 5. Okay. Hold on, I'm going to show you my graph in just a second. All right. Excuse me. So we're going to graph 5 comma 210 degrees first. So 210, we start here and we rotate 210. 210 degrees is actually in the third quadrant, and it's pretty close to this axis. So you're probably looking right around in there. Okay. So this is 5 comma 210 degrees. Now, that's a positive 5. We want a negative 5. So the negative 5 just means that we are doing the opposite vector. So this is the 5 comma 210 degrees. So the opposite vector of this just switches directions. So here's the 5. That means over here it'd be up at about 30 degrees. So probably right around in there. That's the answer right there. This guy. That's the negative 5 comma 210 degrees. So you plot it as a positive vector first, and then if it's a negative vector, you just take the opposite of where you ended up. Go the opposite direction. So we're looking for a picture that looks like this guy right here. So if we come out here, and the answer is going to be D. So there's the first picture. Okay. So right here, this is the positive 5, 210. And then the opposite would be over here. Okay. Now, they want us to provide they want us to provide some other points. And they want to know which one of these is not equivalent. Okay. So let's talk about how we can do this. So when I teach this and when I talk about this, we talk about how we can take the given degrees, okay, and we can go coterminal to it, all right? Sorry if my brain is a little scattered right now. So we can talk about being coterminal to this, which means that we can end up right back at the spot if we go around 360 degrees. So we can add 360 degrees to this, and we can subtract 360 degrees to this, and end up at a spot right where we want it to be at. Okay? So two other angles that are equivalent to this would be negative 5 and 210 plus 360 is 570 degrees. And 210 minus 360 is negative 150. So these are two valid pieces that we can work with. We can add 360 or subtract 360 degrees. The other one that lets us know that it's equivalent to that is when we work with the positive version here, this 5 comma 210 degrees. Okay. And from here, we can take that angle, and I believe we deal with we add or subtract 180 to it. Let me double check that. Pretty sure. Just verifying some things. Yes. So on this one, we're going to add or subtract 180 degrees to get back to this guy. Okay? Because all we have to do is go halfway around the circle. All right. So two answers that we like here are 5 comma and 5 comma. So 210 plus 180, 390 degrees, or 210 minus 180, 30 degrees. So these two are also equivalent. Oh, not 360, 180 degrees. So now we go back and we check, and we'll see which one of those four are not here. So negative 5 comma 390, that's it right there. That's the guy that we don't like right there. Because the other three down here are all listed that we are all on our list that we have. Okay? So this is the guy that is not equivalent. So you're going to throw out answer A because that's not on our list. We have a positive 5 comma 390 degrees. Okay? And then the last but not least, we want to turn this piece into a rectangular coordinate. Okay? In order to turn that into a rectangular coordinate, we have two formulas. X is equal to R cosine theta, and Y is equal to R sine theta. Okay? So it's just a plug and chug. Because in polar coordinates, this is your R, this is your theta. Okay? So X is equal to negative 5 times cosine 210 degrees. And Y is equal to negative 5 times sine 210 degrees. And I believe they're going to want these to be accurate answers. Yeah, include any radicals. So that means you need to make sure that you know what 210 degrees is. What are their answers? So sine 200 or cosine 210 degrees is negative square root of 3 over 2. So this is going to be negative 5 times negative square root of 3 over 2. And over here, this is going to be negative 5 times sine at 210 is negative 1/2. So in the end, we get the rectangular coordinate of 5 square roots of 3 over 2, comma, 5 over 2. Because a negative times a negative is a positive. The 5 will just multiply the square root of 3 and stay all over 2. And then the 5 will just multiply the 1 and stay on top of the 2. Negative times a negative is a positive. And there's your rectangular coordinate. Okay. Number 18, 11.6, because we haven't changed. Number 18, 11.6. All right. So on this one, we are giving you the equation. We want to convert this into the polar equation. Okay? Well, just like what you saw on the other page, that just means that we need to get rid of these two guys and bring in the thetas and the cosines and the r's. Okay? So remember on the other page that we just said that x is equal to r cosine theta. And that y is equal to r sine theta. We'll go in here and replace these. R cosine theta minus r sine theta is equal to 9. All we need to do is get the r by itself. What do both of these have in common? Both of them have r. What can we do? Pull it out like a GCF. How do I get rid of multiplication here to get the r by itself? You divide. So cosine theta minus sine theta. Cosine theta minus sine theta. And there's what R equals. Cosine theta minus sine theta all over, or 9 all over cosine theta minus sine theta. That's what goes in there. Okay, it's just a simple substitution and then get the R by itself. 19, almost there. Almost there. All right, so this one, it says, given this equation, R equal to 6 cosine 2 theta, they want to know which one below is the graph. Well, easy. Go to your calculator and graph it. I'm just going to go ahead and clear all that out. Let's go into mode. You will have to change your mode, and you are in polar coordinates. So make sure you go over here and select polar. And then now when you hit y equals, notice it says R equals. Put in your equation. 6 cosine 2. Hit your X button, which throws in theta. And hit graph. There it is. Now you know what it looks like. So all you got to do is come out here. And the answer is, I believe it was C. Just double checking, make sure. Okay, my calculator doesn't want to come back up. There it is. Yep, C. Let the calculator do it. Okay. Last but not least, number 20. This is it. This is the end, 11.6. So R equal 10 cosine theta. They want you to convert this into a rectangular equation and identify the graph. Okay. All right. So we need to convert this into its rectangular. Obviously down here, you kind of got a hint. The thing looks like a circle. Okay. The thing should look like a circle. Even better is we're actually going to know what the graph looks like if we just come back up in here and just say 10 cosine theta. So right there's your graph. And it is a circle. This is just not squared up. If you hit zoom and hit square for number 5, zoom square, see it's a circle. So you actually already know the answer in the end. You know what this thing's going to look like. It's going to be D. Okay. So the graph is D. So the only question is, how do we get to the equation? All right. So here's how you're going to get to the equation. So this guy, we need to turn it into something that we can work with, okay? Like, for instance, this almost looks like the equation. Sorry. This guy right here almost looks like this piece right there, okay? It almost looks like that. So how can we get this and force it into here? Well, what we can do, what we can start to think about, and I'm losing my train of thought on this. I don't know why I have forgotten how to do this one real quick. Give me just a moment. I apologize. For some reason, this one is eluding my mind. Of course it is. It's the last one. Oh, I remember. So what we need to do is we have some equations that can help us out. Okay. We need to, excuse me, square both sides, because there are some things that we know. We need to force an R in here because this thing almost looks like this. Okay. So if I can get an R over on this side, I can change that to X. And we also know that r squared is equal to x squared plus y squared. Okay? So what I'm going to do is I'm going to multiply both sides by r. R, r. And that's going to give me r squared equal to 10r cosine theta. And now we're going to substitute in. We know that r cosine theta is x. We know that r squared is x squared plus y squared. So that's what it looks like now. All we're going to do is move this over here with the x and then convert that into a circle equation because it is a circle equation. So minus 10x minus 10x, that gives us x squared minus 10x plus y squared equal to 0. And what you're going to do now is you need to complete the square on this. Okay? You need to complete the square on this. So what you do is you'll end up having x squared minus 10x plus 25 plus y squared equal to another 25. Because in order to figure out this 25, remember you got to figure out the c value that makes this factorable, which the c value is equal to the opposite of b over 2 squared. Okay? Sorry, not the opposite of b, just b over 2 squared. All right, no opposite there. I just put a lot of white out there. And so when you took the opposite of 10, divided it by 2, and squared it, that gave you, sorry, not the opposite, but negative 5 squared, which was 25. That's where that 25 came from. Now this is factorable. It becomes x minus 5 squared plus y squared equal to 25. And that right there is the equation that we want. That's the one that we were looking for. So if we go back here, right there, the answer to the equation is B. Okay? And that right there wraps up the exam 3. That's what you need to know. That's what you have to be able to do. And I wish you luck. If you have any questions, feel free to reach out to me. Let me know what I can do for you. You guys are all good.